Hi friends, in GATE lecture series 20, let us discuss few GATE questions on theory of computation. G is a grammar with productions. The production rules are given here and S is the start variable. Then which one of the following strings are not generated by G? That means we have to identify the string which is not generated by these production rules. Let us consider the option A, that is the string is abbab. This can be considered with the production asb, using this production rule asb. Again, this S can be replaced by this production BSA, and this S is also having a epsilon production, so that means you substitute that is empty epsilon string, so you are getting the first option ABAB. Let us consider the option C. The string is ABBAA. Use the production SAS. Again, the first S is replaced by this production rule SSAS. Now the first S is replaced by ASB, and the second one is replaced by BSA, and third S is replaced by epsilon, that is empty string. So now we are able to get the option C also. Now let us consider the option B, AAAB. Use the production rule ASB, and this S is replaced by this production rule SAS. Now we keep the first one ASA as it is, and the second one is replaced by the production rule SAS, and use the production S is replaced by epsilon, that is empty string. We are able to get the option B also. So option D, BABBA, use the production rule BSA. Now this S can be replaced by double S. Again this S can be replaced by ASB, and this SA will remain as it is, but B cannot be generated alone. So the answer option D is the string which cannot be generated by this grammar. Next question. Consider the deterministic finite-state automaton as shown in the diagram. So the given DFA runs on the alphabet zeros and ones, and four states are given: S, P, Q, R. S is the start state and P is the final state. So we have to identify the string generated by this DFA. Let us see the DFA as shown in the diagram. Start state is S, and this start state can have 1 or 0. If it reads 0, it goes to R, but the problem is R cannot reach a final state P. So there is no chance of having 0 from the start state. So the only way is 1. So the string starts with 1, and this final state P, it can contain any number of zeros, first one, or if it has 1 and reaches the state Q, and it has to come back to the final state P on reading 1 again. So that means it can have any number of zeros, or and any number of 1 and again 1. So that means the answer is option C. You may have a doubt why we have ruled out. That means we have not considered the state Q to R, because once you reach R, you cannot reach the final state. So these two transitions are need not to be considered. Next question is, which one of the following regular expressions correctly represents the language of the finite automaton given below? Let us find the answer by observing this diagram. Let us start with the initial state P. So initial state P, then if it goes to Q, then it can come back to P. So what does it mean? Read A, then any number of B's, and again you can read B, it comes to state P again. Then what is the other possibility? Initial state P, if it goes to R, that means read B, then any number of A's, again read A, it can come back to initial state B. So these two are the options. Now this can happen any number of times. That means you can do the same thing again and again. So that is why we are combining these two and put a star here. That means 0 or more combinations of these strings. And there are two final states, Q and R. So if P then final state Q means, that means if Q is the final state, so what is that? A and any number of B's, that is 0 or more occurrences of B. And P then final state R means read B then 0 or more occurrences of A. So now we can combine this and this, so that is the final answer. So option D is the answer now. Consider the context-free grammar G. The protection rules are given here for S and X, where S and X are non-terminals and A and B are terminal symbols. The starting non-terminal is S. Which one of the following statement is correct? Here, four options are given. That is the language generated by G. The option A and option B and option C. And option D is the language generated by G is not a regular language. So let us find the answer. The first protection rule, S, that means it is replaced by ASB or X, implies that equal number of A's on the left and equal number of B's on the right around the string produced by X, because S can be replaced by ASB or X. So certainly A followed by S, then followed by B. This S can be replaced only by X. So equal number of A's, A to the power of N, Y, then B to the power of N, where Y belongs to the language of X, that is language generated by X, N value greater than or equal to 0. Now let us see what is the language generated by X. So the protection X implies that AX or XB or A or B. That means A or B prefixed by any number of A's and suffixed by any number of B's on the right. This X can be replaced by A or B. That is why we say that A or B prefixed by any number of A's and suffixed by any number of B's on the right. So now the language generated by X is A to the power of I and Z and B to the power of J. What is the Z? Z belongs to A or B. It may contain A or B. When we combine both these expressions, so what we get, a to the power of n, a to the power of pi, then z, b to the power of n, b to the power of j, when z is contained in a or b. So now what is the answer is the option B, that is 0 or more occurrences of A, then A or B, then 0 or more occurrences of B. So the option B is the right answer.